Good afternoon, friends. My friend architect Madhav Raman, where is he? Is there, and my predecessor, the people from the LPS yacht, they have brought us all from the high rises to the ground. They have talked about steel close to the heart, steel more firmly binded, and I'll also be talking about the low rise things. Not the high rise. We know that steel in high rise buildings is an important issue, important subject, and we all want to make this country more and more steel intensive construction through those high rises, and where the apprehension, the concerns of the users are more, as Mr. Tomar explained in the morning, certainly we'll be able to find the answers. But what I'm going to talk about is not a technical presentation. Let me make it very clear. I am going to talk about a problem in the country and where steel has a solution. Since this is a steel summit and the topic I am going to talk will try to bring in some points, will try to add a little bit to our knowledge about the contribution of steel in that particular segment. I think housing and light steel structures. There are two reports, if you can download from the net, I have got them but I am not showing those due to paucity of time. National Housing Bank report 2014 and report by JLL 2013, they both indicate that urban population will increase. There is a shortfall of 18 million houses in the urban area and 40 million in the rural area as of now in the country, and there will be a major shift in the urban population from 30% as of now to the 40% in 2030. Out of these single story, 3-4 story houses shall be almost 60%. Our current practices and technology of mass housing do not cope with the requirements, hence there is a need to produce new technology, to use new technology for speedier, safer and lighter houses. Changes are needed in the construction materials and methods. Architect Charanjit Singh ji told in the morning, we need to think in different terms. Technology in terms of material also, like Mr. Hariom Gera presented, some composite is adding to our benefits. And methods, new technology need to be introduced, results of research should be utilized. We study, we read lot of books, magazines, journals, but when they really come to the practice, it takes 15, 20, 25 years for them to be implemented. We must come beyond the codes also. Our codes take lot of time. Myself, Miratra Sahab, Tandon Sahab, we sit in the code committees. We know that we talk a lot and then it takes years to be implemented to the code. We are discussing revision of the IS 875 part 3 since almost 10 years now. After 87, since 10 years the draft code is in circulation and it is yet to be implemented. So we need to use the results of the research. Why? The objective is lighter, faster, easier, durable, economical, safer. These are the all parameters that we need in a house. When a common man, when a poor man looks for a house, he doesn't know who is the structural engineer. He looks for some of these things. So better, as a structural engineer, we contribute to some of these parameters. New technology needed for material, for proper soil investigation. We had a long discussion earlier in the day. There is a big issue with the soil testing, the soil report, the interpretation of the soil results, and its use by the structural engineer. Unfortunately, the soil consultant and the structural consultants are two different people and they rarely discuss on the things. Excavation, all good places have been exhausted for the construction. Whatever sites we have, they are challenging sites. There are buildings existing, we need to excavate deeper. We face every day a new problem. One building collapses, something different happens here or there. So technology in excavation is needed. Technology in the form works are needed. We know nowadays new things are coming. Most of you are aware of them. Reinforcement work in RCC, right from the cast in situ on-site reinforcement cutting binding to the prefabricated cage, that is now coming in India, and it's almost at the same cost. JSPL people are here, I believe. You are supplying those prefabricated cage also. Welding and bolting, unfortunately, most unattended part in this country as of now. Skilled welders. Bolted connections, know-how about the bolt, their standards, specifications, we need to implement new things. Erections and assembly, safety on the construction site, something which is highly ignored. Environment, we need to take care of the surroundings right from the construction site which is on a main road in a city or a market where we create lot of hassle and we don't bother about the surrounding people living there, to the overall environment which we disturb by excavating, by making bricks, using them and all those things. Energy efficient housing, we never bother generally in a house residential, how much energy losses are there from the roofs and walls and all that. Cyclone resistant housing, sustainability, etc., etc., so many things. Speed is one thing which adds to so many benefits. We have discussed about the speed earlier in the day also. Speed otherwise adds, if I finish something, I get more time to other works. If I finish something early, I am happy. If I finish something early, I am ready to do something new, to learn. If I do something early, I get the benefit on my investments early. If I do something early, many benefits are there. So, some of those things I try to put here. Traditionally, I am just taking you back, housing. We means ancestors, here, 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 here. These also more common forms of the houses. 2, this is a real picture from Delhi NCR. We have started using these things. Steel frame, lightweight blocks. We know, okay, this is good. Not much of them, but this is a house in Delhi NCR itself under construction. From here to this tall building which I was talking in the morning, this is 15-story residential building in Jammu, almost completed, finished. No concrete, all structural steel frame with the boards on the wall, double skin and with the insulations. So all the problems of heat, acoustics, sound transmission, decibels, everything is controlled the way you want. My friend architect was talking about that. So you have got all those possibilities. You can control, you can play with your parameters very nicely with this. And this building is ready in Jammu, earthquake zone 5. We are associated with this project. Actually, over the years, we have been using brick walls or concrete frames, infilled walls, brick only as the construction material. We never thought that bricks can be replaced. Maybe we were not getting the good material. Then slowly fly ash bricks, AAC blocks, they have their own challenges, but we are still with the blocks only. Recently we have realized that we don't need them. Why we need that wall kind of partition? Why we need this? Only required for environmental protection, comfort, safety feeling, privacy and nailing, Indian practice. I want to put a nail everywhere. मेरे घर में अगर nail लगाने की जगह, I can't do the pre-definition. I just can't ask everything will be on a level where I will be having one wooden rafter moving, one wooden strip, where all the nails and screwing will be done there. No, no, no. I want that freedom. I want to put nail everywhere. So that is why I need wall. If my nailing practice can be controlled, I can get rid of the walls. I am ready to sacrifice that wall only for that purpose. The dead load of the walls and superstructure is almost 8 to 10 times. All of you do the structural analysis. Just take the sum of the dead load reaction and live load reaction. Do a ratio. It is 8 to 10. Tremendous. For a 2 kilonewton per meter square loading, you are paying for another 12, 14. My friend Hariom Gira said 14.5 tons per meter square. Live load is how much? Hardly anything. It's a huge amount of thing. You are paying for something which is load. Time consumed is much more in execution than planning. We start working on the site, we start constructing without thinking and dump material every day, and then we never bother about the end time. We don't plan, we construct for long, while in the steel it is the reverse way. Material management is an issue. There are several issues. I curse my neighbor when he constructs the house. When I move on the road, I curse the person who has dumped that construction material. So material management is always an issue. Site पे material कोई ज़्यादा आ जाता है, जिसकी ज़रूरत नहीं है, जिसकी ज़रूरत है वो पता नहीं कहाँ रह जाता है. प्री इंजीनियर्ड बिल्डिंग बनाने वाले जानते हैं, जिस ग्रिड का मटेरियल चाहिए वो बाद में आता है, जिसका नहीं चाहिए वो पहले से साइड पे आ जाता है. So those kind of material management issues are there. Quality monitoring is a misnomer. हम quality monitoring की बात करते हैं, there are IS codes and laboratory testings and other things, but nobody really knows and nobody is bothered on those housing. I am not talking of the high-rise building. That 2, 3, 4 floor houses, when Noida, Greater Noida, Gurgaon develops, surrounding villages, they start grooming up. They start developing. Every plot owner there thinks of the business opportunity. He constructs a 4-story house, starts a paying guest accommodation, starts a hotel, starts a restaurant, starts a shop. So he makes a house of 3, 4 floor without consulting. Why? What is the need of a architect, structural engineer, soil consultant, a supervisor on a 4-story house. No, every contractor is an engineer. So quality monitoring is not there, and there's a big lot. If you look at the Nepal earthquake disaster, if you look at the Bhuj itself or anywhere else, Kashmir, anywhere else, it's all those non-engineered or low-rise engineered structures even, which are responsible for the biggest human life losses, not the high-rise building. Whenever somebody of my friend asks, आप structural engineer बताइए नोएडा में इतनी ऊंची building बन रही है, इसमें book कर लें क्या flat? Say yes, go. All the high rises are safe, provided they are in good hands, and normally they are. So, and better options are available. Load bearing walls in RCC frame are to be replaced. That's the technology we want, which consumes time. Structural steel, is it a new technology? No, steel is an old thing, very, very old. The only thing is how to use it, that's the new technology. So what is the new? The new thing is light gauge steel. Thin sections, thin members made in a different way to be used properly. Worldwide people are using. Cold forming is a very good process, very standard process where the material properties are enhanced in the hot rolling. And walls, bricks are not the only solution. We have got lightweight blocks, we have got variety of boards, we have got boards with framing, those are the options for the walls. These walls are not simply infill walls which add to the dead load only, which add to the mass only, which do not add to the stiffness, they add to the lateral stiffness of the building also, these framing. And it's like a load bearing wall but for lateral load also. It's a report I am just showing you from the worldsteel.org. There is a website, you all can log into that, wonderful information and there. So they say, there is a data. Overall 1606 million ton steel produced in 2013, out of which 52.2% goes to the construction, huge contribution in the construction. So any change in the technology in the construction sector will help a lot in overall economy of that country. And we were talking in the morning that our neighbors are doing a lot of good things. We are second in the population in the world but fourth in the steel production. We produce, that gap between second and fourth is big, very big. We are far behind. We are only about 80 million tons of production. Please correct me if I am wrong. Sushil ji बैठे हैं यहाँ पे. We are producing about 80 million ton in this country. Total steel, JSPL, 80. So China is 800. We are far behind. No, more than 1000 now China. Out of 80, we even export, I think some 7-8 million tons. नहीं चरवते, हमें चाहिए नहीं, आप ले जाओ. China beyond 800, they further import. So that's the difference in the overall usage. So developing countries on a 58% and developed 35.9% in the construction, we have lot of scope in that. What I am going to emphasize, what I am trying to put here is that there are sections of this type which are different, which are not a routine thing, which are not the hot rolled angle channel T section girders and all that, but these are the thin sections, cold form, and various forms of the cold form sections which are developed by American Iron and Steel Institute. Again, if you go to the American Iron and Steel Institute website, lot of good material is there for us, those of us who are interested in studying about the steel, AISI, and lot of things are available freely there, good knowledgeable part of the thing. So these are some of the shapes. You can see this one. They are very strong column sections kind of things, very strong, and trusses. And thickness ranges from 0.75, 0.8 millimeters to 2 millimeters, that's all. They are not in the range of 3-4 millimeter even. And you can produce these kind of things. These are Indian pictures. Mass housing, create lot of them. As a brief about the cold form. What is a cold form structure? I am going to talk about the use of the cold form sections, light gauge cold form sections in the housing sector. Housing means when I say ground 1, 2, 3 floor, not too high. You can make 15-story building. We have used cold form light gauge sections, but as a filler wall panel, not as a vertical gravity or lateral wall panel, as a filler wall panel. There also they have helped us in reducing the overall weight, in faster construction, in better walls, all those things are there. In Jammu, because there will be a lot of cold, temperature goes down, so they are happy. All those flats are booked because they are much better quality as compared to the bricks. So made from the structural quality steel sheet formed into shapes either through press baking. There are two processes of making: press breaking and or by roll forming. There are two methods of making the cold form shapes which are shown earlier. Like this, these are some of the, this is one very commonly used section SC channel type of section with the lips, and there is a hole here for the connecting and services. This is the way it looks. This is how concept is converted into a AutoCAD or any software based layout that can be fed into a machine. That machine reads all the requirements, and the machine is also fitted with the software, but it is not that only that machine can do the design, we can do manually also. There are well defined processes for the design of the cold form section, but the technology has gone to a level where there is a whole machine which is a CAM machine, drafting as well as designing and manufacturing both. So that machine will read this data, will produce these components of all the required size of the dimensions of that particular house or the structure, and then assembly will be done once those components are ready, assembly on the site, construction. So this is how the whole process is completely automated. These are some of the design parameters we know. It is not like this that we can design them only for the residential loading of 2 kilonewton per meter square. We ourselves have designed several structures in Delhi NCR using these type of construction up to 1 ton per meter square of the floor loading. 1 ton. Delhi government sub-registrar offices all across Delhi, several, they have made 13 I believe. Vandana, how many? 13. 13 at different locations. They are ground plus 1 structures of different sizes. There we have designed the first floor for this 1 ton per meter square loading of those sub-registrar offices. All of them are like this. Other parameters of wind, earthquake as fire rating 1 to 4 hours. NBC class A type of structures you will need 4 hours. International practices are there, well established international practices. Unfortunately in India our IS 801, the cold form code is old, it needs revision. I think we will take up it with this NBC revision itself. NBC 2015 is coming by the end of this year, and probably we have had long discussions on that in recently concluded meeting, and we will get the new version hopefully by the end of the year. Some more information about the design practices. I am not taking you to the design theory. This is not a time to talk about the mathematics behind it. It is only about creating awareness and to tell you that the know-how is available in the country. The information is available. हमें पता है कहाँ है चीज, कैसे करना है, and internationally from where the support can be obtained, it is there. Almost every developed country has got very well developed literature on that. Indian code provisions we can follow like this. Good international certification is there on the material which we are using, those sheets which are used for the manufacturing of the channels, those boards of different varieties, right from the gypsum board, fiber cement board, and other quality of the boards are there. Friends from Everest are sitting here, they know, they also manufacture. So they are good quality things are with proper certification. Means whatever material you are going to use is certainly a quality product with IS, ISO and every kind of certification. That is the guarantee of the thing. Some of the steps of when you take up a design, how to take various parameters while designing those small structures, but in case of trusses, I will show you a structure where a multi-purpose hall has been made by us, 20 meters of span can be made with these cold form sections only, the channels. The construction process as defined internationally, this is not the Indian scenario, but the one of the report says in general it should take 2 days laying the foundation, 3rd day filling the beam foundation, 4th day wall structure, 5th day footing, flooring and external wall board, 6th and 7th day wall insulation and board, 7th, 8th and 9th day external rendering, 9th day they say our house is ready. This is some international projection. If I multiply by some days, say 10, I multiply this to 10 times. So in India we should be able to do that in 90 days at least, a house. In general, in India a house will take anything 6 months to 1 year minimum with the finishing. So we will certainly save on time, but time saving is not the criteria. Let me tell you very easily, very openly. We are not talking of the time saving only. We are talking of the many other benefits that we draw, provided, that provided is a big question, we will come to that. Something like in Indian scenario, it goes like this. Now, one of the important component of this construction, How many minutes I have spent? Saurabh? 20 is over? Okay, give me some 5-7 minutes more. So this is the wall, very well defined wall with all the components. The component, the insulation, the external facade, the fascia. You can make 200, 143 external wall, you can make different thickness of the wall with insulations and everything, and the material inside. Of the desired properties, what are those desired properties you see here? You can have fire rating of right up to 270 minutes with different combinations. You can have acoustic insulation as good as 50 dB reduction. So that sounds well, I believe, sir. Different components, just showing them, not going into the details. Typical accessories, you can put services inside. These holes are there, predefined holes are there. All the conduiting, all the boxes, everything goes. Windows, this staircase, a toilet inside that. These are all real photographs on site. This is, none of them is the view kind of thing. Some more details of the fixtures. External insulation finishing system. This is EIFS, is one of the very important component where different layers are there. You can do rendering on the external facade of any of these types so that you can achieve any desired pattern and form. There is more details of that. Loss of heat from wall is much more, so if you insulate the walls, if you use a good thing in the wall, you save a lot on the energy. This is the comparison, 4 inches brick wall, 8 inches brick wall, while these are the EIFS walls. The R value, does it help? So quite a good R value with this as compared to brick. Some of the common questions which people ask, CFS framework constructions are more expensive. Under present market prices, the direct construction costs are at par. No, I don't agree. It may be a little higher, it depends, it varies from place to place. If my government will provide some policies which can reduce the cost of some of the components, the cost will be at par. But CFS could lead to a higher ratio of the carpet to built up area. This is one of the very good things, that you get more area under the same built up, under the same external area, get more carpet area inside. You get less weight of the overall structure. Less means much less. I don't need to go deeper foundations with the footings, big ones and bulky. I can simply place the foundation right at the minimum required depth of the foundation. We have done at JSPL Raigad, 0.5 meter depth foundations and ground plus 3-story buildings, standing well, being used also with the same technology. Comparison, RCC big foundations, either lighter, time tested, commonly used in India. It is a new technology, certainly. Anything new, we need to make people educated about that. Flooring, you can have similar. Everything is well sealed. No maintenance is required in these kind of things. Whatever products you are using, you don't need a routine, you don't need a plastering and coloring and everything every now and then. Even the weathering effect from the external environment is much less on these things. This is one of the very important slide which you all must pay attention to that, Meradra sir. Do you expect this to happen to an RCC building? Yes. Do we say yes? Sure. When? After how many years? Pardon? After 15 years we expect this high level of corrosion? I am talking of this, you see this one. This bar is not only corroded, it has broken, the ring has gone from the place and the building is 9.5 years old. That's all. Exactly, it depends. RCC depends. The whole problem, RCC depends. A building which is supposed to last for 60 years, if properly made for the cost about which we are talking, it is within 10 years. These are the pictures of 10 years only. Threat on 13 to 21 story buildings in NCR itself. But the study on the steel, the galvanized steel, the normal steel, the corrosion rate is such that the average life is 280 to 1000 years, average of 611 years by the time it will lose its complete thickness. So it's much more. I don't need for that much. So people who say that steel gets corroded, yes, but to reduce 1 millimeter thickness of that steel due to corrosion, I'll need years. by the time I will be over. It will be more than 6 years for sure. So no worry about the corrosion. Only thing, it looks bad. It doesn't look good. So when your house plaster external side, when your toilet leaks and all those patches are there, it looks bad. So you maintain it here also. So that's not an issue. But this is certainly far better material as far as corrosion is concerned. The weight is almost 1/10 as the calculation shows. This is one of the project in Maharashtra, a resort structure, ground plus 1. These are the actual construction photographs of that ground plus 1 structure. Everything, staircases and other features. This is one school in Vapi. It's a huge school, big, maybe more than 10,000 square feet of the area. It is vertical extension of an existing. The advantage, they were not able to add one more RCC floor on that existing school because high importance factor, earthquake, this, that, everything. So the only solution was a lightweight construction. So we did the whole light gauge frame, double wall insulation with the boards and everything, and the school was successfully able to add one more floor over that. A multi-purpose hall where I was talking in, where is that location? Uttarakhand? There are options for more than 3-4 floor. You can have hybrid structures. You can have the hot rolled steel frame for the gravity and lateral resistance and LGFS wall panels inside. So these are the good options, which are a very good combination which we have used. Extension of the existing buildings you can do like this, and the whole good thing is everything comes prefabricated, everything is off-site. You don't need to do on-site things, only on-site is the assembly. You don't need very heavy foundations, not the stronger. You have to simply do a proper connection with the existing structure. This video, I don't know, I'll just show you. Okay, I skipped this video. I'll leave this presentation here with MX Media and I'll ask Avneet to share it with all the participants. Okay, and it will be a PPT itself in the editable version. You can use it, all the things along with these links I'll show. So there is a whole lot of literature available from AISI, Canadian Standard Association, Canadian Steel Association on the cold form, as well as Center for Cold Form Steel Structure, University of Missouri, Rolla, USA. It's a fantastic place for cold form structures to be learned, where all we use steel in a house. It's an illustration, I don't. This is very interesting. Someone said, everybody knows the name, but I just putting without a name. Someone said, since India is a poor country, only good quality product should be used. Maybe a bit costlier initially, but require much less recurring cost. We cannot afford maintenance. That's our problem. We are poor. We cannot afford the maintenance. So we should use the products which require less maintenance. Due to lack of awareness about quality of construction and inadequate monitoring regulations, the average life of dwelling is only about 30 years as against 60 years normally. So whatever cost we feel initially, if I say initially it is 1,000 rupees square foot house, actually it is 2,000 rupees on the RCC because the life is reduced. On the steel, it is not 60, we are saying 60, it is more than 100 year always. At the end of that 60 or 100 year also, you sell that house, you will get more price than for what you have built. Remember, you will get more value. And therefore the technology of producing these branded houses should be better developed. I call them branded house. We are ready to pay a little bit for the branded house, and we can develop this technology at a rational cost. So friends, it is time to think and change the mindset. We must understand that it is not a costly thing. The only thing is we have to ask government to make such policies that we get the products at reasonable cost, so the overall housing problem in the country can be addressed at a rational cost. The people who are spending money can really get good quality product. We are not going to sell them the houses, we say 60 years and not good at 10, 20, 15, 25 years. When we look for branded items everywhere, why not we look for branded house? Why don't we put a plate? Support from government is required in terms of policies that will make the cost of these new technology, though globally accepted, it's not new for global, rationally priced. It can be done. Day is not far off when we will enter a showroom of the houses with our requirements, and a modular and pre-engineered, prefabricated house will be ready to be delivered in just weeks and not months or years, friends. And this is one house of similar technology we are going to make. We are designing and it will be this way. These are the views only, but it will be like this only, and no difference you can see. No, sir, these are the views, and the house finished will be like this without any difference, but finished houses of this type are also available. We can share those actual. Pardon? Something around 1200. Yeah. Something around 1200 for without finishing, without the internal things and other things, for the structure and walls. Probably people are sitting around you who can support that rate. Sir, Sushil ji कितने में देंगे बना के? हाँ? The land price is separate, but around लीजिए. There is one more better option, 1000 rupees square feet. So here I wind up the presentation with the hope that we all will learn more. When we say steel, we only think about the hot rolled steel. When we think of the steel, hollow sections, big structures, high rise buildings, big airports and everything, they are important. And naturally, as Madhuraman said, that when it is a big long span structure, the natural choice becomes the steel. But here the natural choice is not steel, you have to make it, because this is also a good thing. So friends, thank you very much everybody, and I appreciate the patience of you all sitting till now and enjoying the event, summit. Thanks MS Media.
Thank you so much, sir, for sharing your immense knowledge with the
Any
audience.
questions? We can talk later because we are already late.
Yeah, we
Mail
have the
me.
panel discussion right
Please
for the
note
same.
down my mail ID here, or they can give. Okay. I don't agree, sir. सर मेरे घर में चोर घुस के मेरी हत्या कर देता है तो दोषी मैं हूं कि चोर? सर सवाल बहुत सिंपल है. मॉइस्चर एंटर हुआ, सर वही स्टील है. इफ दैट इज रिमेन प्रोटेक्टेड विदाउट मॉइस्चर, दैट स्टील विल लास्ट फॉर इयर्स. वो मॉइस्चर जो घुसा ना, उसने उसकी हत्या कर दी. सर इफ यू डोंट प्रोटेक्ट, इट विल लास्ट फॉर 600 years. If you protect for 1000 years, that is the difference. No, sir, RCC there is a big challenge. There is a different thing. Inside the RCC, because the bar is binded in the concrete, the volume of rust is 8 times the volume of the original iron. When that external layer gets oxidized, it increases by 8 times, and there it bursts the concrete and you get the vertical cracks on the surface. That is where is the problem. And the concrete becomes disintegrated and crumbles and the loss of the strength occurs. It is not only the steel which is the culprit. Because of the steel, the loss in the strength of the concrete is the problem. If on, pardon? It is the concrete which is culprit only. See, moisture is there to, see, चोर तो आपके घर में बाहर हमेशा ही घूमता है ना. Culprit आपका दरवाजा, आपका घर, आपकी आदतें हैं. So we have to remain safe. Yes, please. I did not go into those details. I just showed that anything is possible, all possibilities are there. I did not go into those details because they are the products and there is a lot of variety of the products available. So my basic focus was on to the use of that technology. Now the choice of the products can be anything. You can apply anything on that. And you can see, yes. आपने बिल्कुल ठीक कहा. मैं ना आरसीसी को दोषी ठहरा रहा हूं ना स्टील को. आपने सुना नहीं ध्यान से. It is the human factor which is involved. The way we construct, RCC by itself never says I am bad. The way RCC is handled makes it bad. See, RCC is a wonderful material. Go to the Swiss embassy in Delhi. 50-year-old building, लगता है कली बनी है. Exposed concrete, fantastic work. Lot of the buildings. Concrete is not the culprit. The way we do it is the culprit. It is our mindset. हमें नहीं करना आता ठीक से. हमारी कंट्री में हमारे यहाँ क्योरिंग नहीं करवाते. There are several factors. I don't want to discuss them. It is we people who are responsible for that. That is all. Pardon, sir? Sir, you bring a bull, dash against that house. I did not discuss about the strength, but there are provisions. People are not using it as a single layer skin. There is always a double layer board on the front side, and that 90 mm channel inside has got such a good impact strength.
We are not leaving the lift of the top class building. This is a very...
That is one thing. It is the village house I am talking, where he doesn't know anything. He has to simply go to a shop, purchase a house, get it installed. Whether that villager gets it installed or you will get the same quality. That is the positive point of this technology.
I am not talking about the quality. I am talking about the time. This is in our curiosity in our generation this is very high. If we know this is the comes out, then definitely it will come out.
Nothing comes out here.
100%.
Sir, nothing comes out in this. In these houses, nothing comes out. They are so well made. They are so sturdy. That is why I am saying it is the need of changing our mindset. Nothing comes out in these houses. You don't feel that it is a board house or something. They are so well made. Their fixtures are so strong, so well designed, and nothing comes out. Their screws are, my friend was talking of the screws, those quality of screws, nothing comes out. They are very well packed.
Only one reaction to be expressed.
Sir.
You said what in the beginning itself that you have made a house and they are standing. Somewhere you said you made it, they are standing well. Fine. Similar situation was there before Bhuj earthquake. All buildings were they not used to the test of time. So now these structures have to stand the test of time.
I perfectly agree with Bhatia Sahab that we have, I do not accept only the performance as a criteria which is seen. I'll tell you, I did not speak one thing. When RCC houses they collapse, they are sure to take away the life which is inside them. When this house will collapse, I know that the person inside is going to live, not only live, but there is much less possibility of his dying. That is another plus point of these houses. इसमें कुछ भी नहीं सर. Sir, during earthquake, yeah, the established sir, exactly. The established lateral resistance of the walls is as per the requirements of that earthquake zone. It is there, and with the ductility.
I'm only saying one word of caution only, that we are starting with these things now. Maybe if you will ask 2 years back, we just to test it locally, like earthquake.
Sir, in India we are saying we are starting. Globally there are houses of this type more than 25, 30, 40 years. Maybe some of them are not in the seismic zones, I agree. But there are places in the seismic zone where we need some modification. Those people, they don't use the cross bracings. We have to use cross bracings. We have introduced the cross bracing concept in the LGFS systems. So that has to be there. Thank you, sir.